Imagine a world where woolly mammoths once again roam the tundra, not as fantasy but as a real scientific goal. The idea may sound like something out of a storybook, but today, it's at the cutting edge of science and technology. Thanks to breakthroughs in genetic engineering, the resurrection of the mammoth is no longer a distant dream, but a project underway right now. Teams of researchers around the world are collaborating, using tools that were unimaginable just a few decades ago. For generations, mammoths have symbolized a lost world, their remains sparking our imagination. These ancient giants have inspired countless myths and stories, reminding us of a time when humans and mammoths shared the same landscapes. Now, with advanced DNA sequencing, we're piecing together their genetic code, unlocking secrets once thought lost forever. Each fragment of DNA is a clue, a step closer to understanding not just the mammoth, but the world it inhabited. The idea isn't just to marvel at ancient giants, but to challenge extinction itself. It's about pushing the boundaries of what's possible and asking bold questions about our place in nature. This project asks us to see the past as a resource, a library of information we can finally access. By studying these ancient creatures, we gain insights into evolution, climate, and survival. Scientists are reconstructing the mammoth's DNA, like rediscovering a lost recipe and gathering the ingredients to try it ourselves. It's a meticulous process, requiring patience, creativity, and a deep respect for the past. Bringing back an extinct species could reshape ecosystems and redefine our relationship with nature. It could help restore lost habitats and even combat climate change by reviving ancient grazing patterns. It forces us to reconsider what gone forever really means. Are we truly powerless against extinction, or can we use our knowledge to rewrite the story? As we stand on the edge of this new era, we're not just reviving a species, we're confronting our role as stewards of the planet. The choices we make now will echo far into the future. The ghost of the mammoth calls to us, and for the first time, we might answer. The promise from the past is within reach, inviting us to imagine what comes next. For years, de-extinction was pure science fiction. Think Jurassic Park and its cautionary tales, but the line between fiction and reality is blurring fast. Today, de-extinction is a real field, powered by revolutionary tools like CRISPR. CRISPR acts as molecular scissors, letting scientists precisely edit DNA. Instead of searching for perfect ancient DNA, we now edit the genes of living relatives using fragments from extinct species. This shift has turned de-extinction from fantasy into a tangible engineering challenge. We're not reviving dinosaurs, but animals like the mammoth passenger pigeon and Tasmanian tiger are now within reach. The challenge is about careful genetic sequencing and sophisticated cellular engineering. We're entering an age where we can rewrite genetic code, turning theory into practice. The era of de-extinction has begun, promising to reshape our world. The question is no longer if, but how soon. Leading this charge is Colossal Biosciences, a startup with a mission as bold as its name. Founded by Ben Lamb and George Church, Colossal is blending Silicon Valley ambition with cutting-edge genetics. Their goal: mammoth-like calves within a few years. Backed by tech billionaires, celebrities and venture capitalists, Colossal has made de-extinction a mainstream conversation. They're not just reviving mammoths, they're developing new genetic tools with wide applications. Their approach is fast, direct, and unapologetic, hiring top talent and building state-of-the-art labs. Colossal frames its work as a mission to heal the Earth, not just a scientific stunt. They're tackling technical challenges head-on, setting the blueprint for a future where extinction isn't final. This is a pivotal moment for both technology and ecology. How do you make a mammoth? It's a question that once belonged to the realm of science fiction, but today, it's at the cutting edge of biotechnology. The answer isn't cloning, but rather editing the DNA of the mammoth's closest living relative, the Asian elephant, a species that still roams the forests and grasslands of Asia. These two remarkable animals share over 99% of their DNA, making them genetic cousins separated by thousands of years of evolution. But it's the small, crucial differences in their genetic code that make a mammoth unique. Scientists meticulously compare their genomes, searching for the genes responsible for shaggy hair, thick layers of fat, small ears, and blood that can withstand freezing temperatures. Using the revolutionary tool CRISPR, they carefully swap out elephant genes for their mammoth counterparts, like performing a high-stakes find and replace in the very code of life itself. The aim isn't to create a perfect clone of a mammoth, but to engineer a cold-resistant elephant, one that looks, behaves, and thrives like a mammoth in harsh, icy environments. Once the DNA has been edited and perfected, the modified nucleus is used to create a brand new embryo, the first step toward bringing this ancient giant back to life. To avoid the risks and ethical concerns of using living elephant surrogates, Colossal is developing artificial wombs, high-tech devices, that could one day nurture a mammoth-elephant hybrid from embryo to birth. If successful, the result will be a living, breathing hybrid, an animal that bridges the ancient past and the present. It's a creature built from ancient genetic instructions, reassembled with modern science, ready to step into a world it's never known, and perhaps help shape the future of our planet. This is genetic engineering at its boldest, where imagination, technology, and nature converge. The mammoth is just the beginning. De-extinction could revive a whole menagerie of lost species. Scientists are working on the dodo, editing the DNA of the Nicobar pigeon to restore dodo traits and ecological roles. The thylacine, or Tasmanian tiger, is another candidate, with efforts underway to use close marsupial relatives as genetic templates. Reviving these species could restore lost ecological functions, like seed dispersal or predator balance. Projects like Revive and Restore aim to bring back the passenger pigeon, once a keystone of North American forests. Each project is a new chapter in the story of extinction, and a test of our ability to repair the past. De-extinction is about more than nostalgia, it's about shaping the future. Why bring back extinct species? The answer goes beyond curiosity. It's about restoring ecosystems. Many lost animals were keystone species, crucial for environmental balance. Mammoths, for example, maintained the vast grasslands of the Ice Age, shaping the landscape and helping trap carbon. Their disappearance led to ecosystem collapse and less effective carbon storage. Reintroducing mammoth-like animals could help convert tundra back to grassland, fighting climate change and preserving permafrost. Similar benefits are proposed for the dodo and thylacine, restoring lost ecological relationships. De-extinction is seen as a tool for rewilding, repairing broken links in the chain of life. It's about using science to heal, not just to marvel. The goal, a more resilient, biodiverse planet. The promise of de-extinction is thrilling, but it raises tough ethical questions. What kind of life would these animals have? A mammoth born today would be an orphan, with no herd or ancient wisdom. Their habitats have changed. Can they survive in today's world, or would they be confined to zoos? Are we creating wild animals or just biological curiosities? The cost is enormous. Should we spend millions reviving the extinct while living species are vanishing? Critics argue resources would be better spent on conservation. There's also the risk of unintended consequences. Could revived species disrupt ecosystems or spread disease? Ecosystems are complex, and our interventions often have unpredictable results. We're venturing into uncharted territory, with no manual for playing God. De-extinction demands caution, humility, and responsibility. Technology is racing ahead, sometimes faster than our wisdom can keep up. CRISPR and genetic engineering are advancing at breakneck speed, while ethical debates lag behind. Decisions with global consequences are being made by a handful of scientists and investors. Who decides which species return? Who's responsible if things go wrong? The momentum of innovation can make these projects feel inevitable, even if society isn't ready. We need a global, inclusive conversation before the first mammoth calf is born. The power to rewrite life is an awesome responsibility. We must be prepared for the world we're creating. Humanity stands at a crossroads. Extinction is no longer final, and we hold the power to reverse it. For the first time in our history, the boundaries between what is lost and what can be restored are blurring, and the decisions we make now will echo for generations. De-Extinction offers hope, healing ecosystems, fighting climate change, and atoning for past destruction. It's a chance to repair the damage we've done, to bring back balance where it was lost, and to give nature a second chance to thrive alongside us. It's a vision of humans as active stewards, not just observers, of the natural world. We become partners in renewal, working hand in hand with nature to restore what was once thought gone forever. But caution urges us to focus on protecting the life that remains, not just resurrecting the lost. The living world is fragile, and our efforts must not come at the expense of those species still fighting for survival. True wisdom may lie in learning to live in harmony with the living, rather than reviving the dead. Our greatest responsibility may be to nurture what endures, to cherish the diversity that still surrounds us. The choice is ours. Embrace resurrection and its risks, or devote ourselves to conservation. Each path carries its own promise and peril, and neither is without consequence. There's no simple answer, only the responsibility to choose wisely. Our actions today will ripple outward, shaping the world for those who come after us. Our decision will shape not just the fate of the mammoth, but the future of our planet. The story we write now will become the legacy we leave behind. We are the stewards of life's code, standing at a fork in the evolutionary road. The tools of science are in our hands, but so is the weight of responsibility. The direction we choose will define our legacy. It will tell future generations who we were and what we valued most. What kind of humanity will we be? The answer lies in the choices we make and the world we choose to create together.